Now let's visit the fun-filled world of lemniscates, if I could say that. Lemniscates. Okay, what a fun word. The formulas that generate the graph of a lemniscate are given by r squared equals a squared cosine 2 theta and r squared equals a squared sine 2 theta, where a is not equal to 0. Obviously, if a equals 0, it's pretty trivial. So the formula for r squared equals a squared sine 2 theta is symmetric with respect to the pole. The formula r squared equals a squared cosine 2 theta is symmetric with respect to the pole, the line theta equals pi over 2, and the polar axis. So we see these four cases. So r squared equals a squared cosine 2 theta looks like this, infinity. R squared equals negative a squared cosine 2 theta looks like an 8 or 90 degrees rotated of that infinity. R squared equals a squared sine 2 theta is going to be this diagonal infinity going up to that pi over 4. And then r squared equals negative a squared sine 2 theta looks like this infinity again, but going the other 3 pi over 4. Okay, so we're going to sketch the graph of an r squared equals 4 cosine 2 theta. So if we think about this, the biggest cosine can be is 1. So we have 4 times 1. And what's going to happen with this, do you think? Given that r squared, if r squared is 4, what is the square root of 4? 2. Okay. Let's think about that. So maybe I'll scale this actually a little differently. Maybe I'll call this 0.5, 1, 1.5, and 2. Make this a little more exciting. Okay. So this is an r squared equals 4 cosine 2 theta. So it's positive there. So we know it's going to be this kind of infinity thing going out horizontally. So let's go ahead and plot some points. We'll do theta. We'll do 2 theta. Ooh, check that out. We'll do cosine of 2 theta. And then we will do 4 times cosine of 2 theta. And then to get r, it's going to be the square root of that. So the square root of 4 cosine of 2 theta. So we have 0, pi over 6. I'm going to put this, even though it's not, I don't have that pi over 4 line, I'm going to put it in here this time. Pi over 4, pi over 3, pi over 2, and then, now they said this is symmetric with respect to the pole and the line pi over 2, excuse me. So once we get that 1/2, we can, that one part, we can reflect it. So we could just check it out and see what happens with 2 pi over 3. Okay, so 2 times 0 is 0. Cosine of that is 1. 4 times that is 4, and the square root of that is 2. So we know we start out here at 2. For pi over 6, that's going to be square root of 3 over 2. Oh, sorry, no, jumping ahead of myself. 2 times pi over 6 is like pi over 3. Cosine of that is going to be 1/2. 4 times that is 2, so we got a square root of 2. Pi over 4, 2 times that's pi over 2. Cosine of that is 0, so we get 0. Pi over 3, 2 times pi over 3. Cosine of 2 pi over 3 is going to be negative 1/2. 4 times that's negative 2. And that presents us with a challenge. So that should be undefined, shouldn't it? Or yeah, I'm just going to go with, because that's imaginary. So that would be I times the square root of 2. That doesn't seem like it's going to work. Let's continue on. 2 times pi over 2 is pi, so cosine sees that as pi. Cosine of pi is -1. 4 times -1 is -4. So once again, we have 2i. And I'm just going to do this next one, and I want to start plotting things, and then we can go with our reflections. So 2 pi over 3. 2 times that is 4 pi over 3. Okay, cosine of that amount would be -1/2 still. And then 4 times that is going to be -2. So again, get I times the square root of 2. Okay, so if we plot what we currently have that one. And then we have at pi over 6, it was square root of 2, so it's like 1.41. So right about there. Then at pi over 4, it's going to be here. So we have this type of a shape. Now, it's supposed to be symmetric with respect to this line here. So we can fill that in like so. And it's supposed to be symmetric with respect to pi over 2. So we can do like this point here would be this point here. This goes out to here. So that's our shape. Now, just these values here are not going to be graphed. And we're really relying on the fact that it's symmetrical. So the symmetry helps us graph it. You could get some more points out of this if you did. I'm trying to think what puts us back into the 4th quadrant. And so that'd be from after 3 pi over 2 up to pi. So for example, 3 pi over 2, 3 pi over 4, I should say. And then we would have 5 pi over 6. So those would be graphable. And those will give us some more values. So, but we're relying on the symmetry to help graph this one. Okay, a little more complicated, kind of a strange one.